Hello everyone, I welcome you in physics classes. Dear students, in my last lectures I taught you about fluid flow and equation of continuity, and our today's and very important topic is Bernoulli's theorem. Students, Bernoulli's theorem, the question is asked in exam that state and prove Bernoulli's theorem along with its one application. So applications also I will send you. Try to understand those applications, but here I'll explain first question, that is state and prove Bernoulli's theorem. Students, Bernoulli's theorem states that total energy of incompressible and non-viscous fluid. Here fluid, I'm talking about liquid. So pay attention. It states that total energy of incompressible means which you cannot compress. Non-viscous means its viscosity we are considering equal to 0, just like your water always remains constant. It will always be constant, but with one condition: if there is no source or sink along the pipe. That means the pipe through which your fluid is flowing, through which your liquid is flowing, it don't have any cut. Neither the water is coming inside nor any drop of water is going outside. If not coming inside means no source. If not going outside means no sink. I hope you understand the meaning of source and sink. Okay, so full definition of Bernoulli's theorem is that total energy of incompressible non-viscous fluid always remains constant if there is no source or sink along the pipe. Okay, so mathematically, let us see what happens mathematically. Mathematically, it is rho means density, rho upon P plus half V square plus GH equal to constant. Now you will think that what is this new quantity? So students, this is nothing. These are the energies. This first energy is new for you, that is rho upon P. We call it pressure energy per unit mass. Okay, second energy you have studied, only M is not here, otherwise it is half mv square, means kinetic energy. That's why we call it kinetic energy per unit mass, means with mass we have divided it. Okay, half. Okay, this is GH. GH means your potential energy. Now again M is not here, so it is your potential energy per unit mass. Okay, I hope the terms are clear to you. Now students, this we need to prove that this total energy remains constant. So for proving it, let us consider this diagram. This diagram you have to draw exactly same. Okay, this end is called as A. This is one pipe through which the water, the liquid is flowing. Two ends I have taken. One end is A, second end I have taken B. And A is little bigger in area of cross section and B is little smaller in area of cross section. But height of point B is more, height of point A is less. Okay, we have taken two more terms here. A1 is the area of cross section, P1 is the pressure. Here A2 is the area of cross section and P2 is the pressure. So everything is written in your theory that let P1, A1, V1 be the pressure, area of cross section and volume at end A, and volume of liquid at end A. Just add this word. Similarly, P2, A2 and V2 are the pressure, area of cross section and volume at end B. Okay, students, now applying equation of continuity. Your equation of continuity is saying that A1 V1 equal to A2 V2, and this I have taken equal to volume. Now again question, how it is equal to volume? So students, if you have checked it, I have written here per second. Per second means velocity divided by a time. If velocity divided by time is equal to distance and area into distance is equal to volume, that's why I have written here volume. I hope it is clear. work done at A. Now what is work done? Work done is equal to force into displacement. So it is force means F, and you know force is equal to pressure into area. That's why I have written P1 A1. Displacement, again it is displacement is velocity upon time, and time is 1 second, so we are not writing, so we are writing only V1. So it is P1 A1 V1, and at B it is P2 A2 B2. So what is the net work done? Obviously we will take the difference. Net work done, from here the work done it is doing, from there also it is doing work done. Here it is entering, from there it is exiting. So the total work done is P1 A1 V1 minus P2 A2 V2. A1 V1 and A2 V2 is equal to V. So put V, V. So V I can take common. It is P1 minus P2 V. So this is net work done. I have enclosed it in one box. So same I want from you also, that highlight the main things. Okay. Now students, let us see the next line. Increase in kinetic energy. How much kinetic energy is increased? So you just tell me that at which point kinetic energy will be maximum. Just pause your video and think. According to equation of continuity, the velocity of liquid at which point it will be more. If you have gone through continuity video, equation of continuity video, then you must know that more is the area, lesser will be velocity. Lesser is the area, more will be velocity. And in beginning only I told you that A1 is greater, A2 is smaller. So here the velocity will be more. So that's why greater one velocity minus lower one velocity. Okay, so half mv2 square minus half mv1 square. This is the increase in velocity, means velocity at end point minus velocity at initial point. How much increase in potential energy? So increase in potential energy means potential energy at the end point minus potential energy at the initial point. Simply you can say that final potential energy minus initial potential energy. I told you so many times in my chapter of work power and energy also that change in energy means final energy minus initial energy. So same is the concept here also. Okay, so I hope you understood. Now according to conservation of energy, students, conservation of energy is saying that energy always remains conserved, means how much work you are doing, energy will be same. So put the value of work done from that equation. So work done is P1 minus P2 V, and change in energy is half mv2 square minus half mv1 square plus mgh2 minus mgh1. Dividing throughout by m, when you divided it, it will be V upon m. Here m, we have divided it m, so m will cancel with m will cancel with m will cancel with m will cancel with m. That means from these all terms the m will get eliminated. Okay, so now I'm using one trick, that all the terms which are considering 1 1 1 I will take one side and 2 2 2 on the other side. So students, here is mass per unit volume. Mass is down, volume is up. So it is opposite of density. So you can say that mass per unit volume is equal to density. So density will come down in denominator. So it is P1 upon rho, P2 upon rho. So P1 upon rho I have taken here. P1 upon rho, half V1 square, and G1 I have brought this side. Terms will change their signs accordingly. Whenever they are changing side, their sign will also change. Okay, so P1 upon rho plus half V1 square plus GH1, P2 upon rho half V2 square plus GH2. That means is equal to P3 upon rho half V3 square GH3. Similarly, P4 upon rho plus half V4 square plus GH4. In the similar way it will go on. That means P upon rho plus half V square plus GH is equal to constant. So dear students, you can see the first and last expression both are same. That means we have proved Bernoulli's theorem. Students, do write the applications of Bernoulli's theorem from the shared PDF, and for any query you are free to call me, you are free to send me text. Okay, so this is enough for today. I hope you understood our today's topic, that is Bernoulli's theorem. Students, this is very very important from examination point of view, its statement as well as its proof. Okay, so this is enough for today. Thank you. Have a good day.